Hello everybody, Mr. Randall here again, and today, for the intro, what we're doing is we're talking about quadrilaterals, types of quadrilaterals, and then we're finding the area of other quadrilaterals than the ones we've studied, so parallelograms and trapezoids. Here is your quizzes code. Go to both of these links for trapezoids and parallelograms. There are triangles in this one, which we will get to later. Maybe you know how to do those, maybe you don't, but just work around that. Types of quadrilaterals, four-sided shapes. And in this group, we have parallelograms, where we would have a square and rectangles, since a square is a type of rectangle, they belong in the same circle. And a rectangle is a type of parallelogram, which is just four-sided shapes with two sets of parallel lines. So these two lines are parallel and these two lines are parallel. Right here we have a rhombus, which is just really best described as the square version of a parallelogram. Equal sides, two parallel sets, not being 90 degrees right here. Then we have a trapezoid, which is defined as one set of parallel lines. So we see right here, parallel lines right here. These sides are not. Okay, and here we just have an irregular quadrilateral. Let's move on to quadrilaterals right here. So a quadrilateral parallelogram, as we can look, it is two sets of parallel lines where they're not 90 degrees. So here, if we have a parallelogram, we kind of have something that I see it broken down as a rectangle and then two triangles right here. Do we see that, how that fits into one parallelogram? Well, now, one thing that you can do, and this is just kind of a little bit of a proof to it, what if we took this triangle right here, and moved it over here? We have it right here. Well, do we know how to find the area of the image on the right? Do we know how to find the area of this? Well, of course, it's a rectangle now, and we can just do length times width. And something that is better defined here is this is the height. We don't want to use what this side length is, because it's not the height. This, the 90-degree angle right here that we see, is. So we want to use what is in blue right here, or green, I guess. We want to find that as our height right here. So again, it's just length times height. So now if we look at a trapezoid is a little different. Well, here we have, again, a set height, but it's going to be harder to find these two triangles, the triangles that are on the ends right here. But what if we took it and made a copy of it? So what I did when I made this right here is I took this red one, made an exact copy of it, and turned it 180 degrees. Then I matched them up. And what shape do we see right here? What shape do we see right there? Well, if we go back to our old slide, we see this, which we know to be a rectangle. But something interesting about this is, so if we're going to do a parallelogram, or make a parallelogram out of this, its length right here is a plus b. Okay? So the area of this parallelogram is b plus a times h. But again, since we only want half of it, we only want the blue one, we need to divide it by 2. And that's how you find the area of those shapes. Let's look at an example. So Marco's family has a garden that has two sets of parallel lines with non-right angles in the corners. So parallelogram. The length of one side is 7 feet, and its distance to its other parallel side is 7 feet. So this is an example of actually what a rhombus is. What is the area of the garden? If it's two sets of parallel sides, we already established that it's a rhombus. It has a length of 7 right here and a height of 7 right here. So we do 7 times 7, we get 49 square units. Final question here. So the area of the stage DaBaby is going to perform has the layout of a trapezoid. To make sure he has enough room to perform, the stage can be no less than 250 square feet. If the stage is laid out like the following, so right here, would the baby have enough room to perform? Well, let's figure it out. So, if we go back here, we need this formula. So let's just paste it right there. We're going to use this formula. So, what the A distance is, we can call it 22. Plus, well, now we need the B value, which again is the two bases. So here's A, the other one has to be the other parallel set, so it'd be 10, all divided by 2, times H, which we can see is 16. The height there is 16. Let's simplify this. So now we'll have 22 plus 10, so 32 over 2. Well, we could write 16 here again, but I know that 32 divided by 2 is just 16. So now this becomes 16 times 16. And if we type that in to our calculator, we would then get, we got 256 square feet. And so we can tell that he would have enough room, because 256, he has more room than 250. Okay. Let's make sure we do our quizzes. Go to these if you want extra help. Okay. Have a good day, guys.